All right, guys, welcome to direct variation. One of the big things you need to understand today is that some quantities are in a relationship where the ratio of corresponding values is constant. I mean, as one goes up a certain amount of units, the other quantity goes up a certain amount of units. And these are linear. Okay, the variables can increase or decrease at a constant rate together. A real-life example of that could be, let's say you have you want to save some money to go to Disney World, and every week you have no money to start with, but every week you get $20 in allowance, and every week you're going to save that $20. So that's an example of something that's constant. Every 1 week you save $20. Okay. Direct variation can be written in two forms. You have y equals k times x, or k equals y over x. Now sometimes you'll see that k be the value a, and we call this value k the constant of variation. Later on you'll learn that as really it's the slope, okay? And when we know it's direct variation, or we want to see y varies directly with x, that's how we read that. So y equals kx, y varies directly with x, okay, and k is that constant of variation. Nice little formula here, that ratio k is equal to y over x. It's simply solving this equation here for k, divide each side by x. So that's how we get this second equation. Okay, so in example 1, we're looking for each function, determine whether y varies directly with x. If so, find the constant of variation and find its rule. The rule would be the equation. Okay, so here's our table in black. Our first table is the x values 1, 3, and 4. Their corresponding y values are 2, 6, and 8. Okay, so if I want to know if this is direct variation, I want to look at the ratio. I want to find k. I want to look at that ratio y divided by x. If all those outputs are the same, great, I have direct variation. So let's look. 2 divided by 1 is 2. 6 divided by 3 is 2. 8 divided by 4 is 2. Now for this relation, this function, I have direct variation. So y varies directly with x. And in this case, k is 2. The ratio of y over x was 2 in all cases, so that makes my rule y equals 2x. That's my equation or rule. Now let's look at b. b, I have 1, 4, 2, 8, 3, 11. Okay, so again, I look at that ratio y over x, and I determine if my k value is constant in all cases. The same value. So 4 divided by 1 is 4. 8 divided by 2 is 4. So far, so good. 11 divided by 3, that's not quite 4. So this would not be direct variation. Okay, even though 11 thirds is close to 4, relatively, it's not the same value, so therefore this is not direct variation. There's no specific direct variation rule for that. Now, in example 2, again, instead of giving a table of values, we're given an equation. So when you look for direct variation with equations, what you want to do is get your y value by itself. So for each question, determine if y varies directly with x. If so, find k. Now, in this case, we don't have to find the rule because the rule is the equation. We've been given two equations here. So let's just solve this first equation, 3y equals 7x for y. Divide each side by 3, and I'm left with y equals 7 thirds. There's nothing following that. There's that y equals kx, and in red, that's my direct variation, or constant variation, excuse me, that's 7 thirds. So this is direct variation. Now, looking at b, I have 7y equals 14x plus 7. The only big difference here is we only had an x term. Here we've got something else. So again, solve the equation for y, and I divide everything by 7, each term, and I'm left with y equals 2x plus 1. I have this extra constant. That can't be there for direct variation. That would have to be plus 0. There's nothing following it here. Okay? So there's a y-intercept here that's not 0. Okay? So this is not direct variation. So that's an example of how do we determine if the equations, linear equations are direct variation. Solve your equation, in this case, for y. Okay, so this is going to take that equation process one step further. Let's say in example 3, suppose y varies directly with x, and y equals 9. when x is negative 15? What is y when x is 21? So this is a two-part problem here. So we know that y varies directly with x. So we know we have some type of y equals kx equation. We know that also when y is 9 when x is negative 15. Okay, and then we want to know what y is when x is 21. Well, we need the rule, we need the equation. So first, we're going to find the constant of variation. Our equation, we were told, varies directly. We know that when y is 9, x is negative 15. So I plug in my values for y and x here. I simplify that to be negative 3/5. That's my k value. So my rule is y equals negative 3/5 x. And I take that over here. So now in step 2, I go to the second part of this equation. What is y when x is 21? So I have my rule, y equals negative 3/5 x. By substituting x in, I can find y. That simplifies into negative 12.6 roughly. So that's what the y value is here. So that's the answer to the equation, or to the question, excuse me. So it's two parts there. All right, a salesperson. Gosh, everybody's salespeople. That's got to be one of the toughest jobs, right? Calling people. Hey, by the way, like the Washington Post calls me all the time, and I have a subscription to the Washington Post. So a salesperson's commission varies directly with sales. For $1,000 in sales, the commission is $85. What is the commission for $2,300? Okay, so we know that this has got to be somewhere over about $180 roughly, because if you doubled, if it varies directly, it's a constant increase. So if it's $1,000 for 85, it'd be 170 for $2,000, right? So we're 2,300, so we're going to be above 170 somewhere. Okay, so I know my equation is varies directly. So where do we start? We start with that idea. Our equation varies directly. C is commission, and S is sales. So I'm just going to mess with this equation a little bit. I'm going to put C where Y is, and S where X is here. So there's my commission is equal to my constant of variation times my sales. So I first know that I make $85 when I have $1,000 in sales. So that means my constant of variation is 0.085. As a percent, 8.5%, right? Actually 0.85%, excuse me. Let's look at step 2. So now I'm going to use that constant of variation to figure out what I make on $2,300. So y equals 0.085 times 2,300, which is $195.50. So that's what I would make on $2,300 in sales. And that's with a direct variation, a constant, okay, constant progression up. It's an increase, okay? In our last slide, let's look at what a graphs look like with direct variation. Now, direct variation is special. You'll learn in the next video about slope-intercept. And the y-intercept here, there's nothing past that. So we're actually, all these direct variation equations will always go through the origin, because when x is excuse me, when x is 0, y is 0. So let's look at y equals 3/4 x. That's my slope, and we'll learn that too. So I can plot some points. I can plug in 4, and I get 3. 8, I get 6. And 12, we get 9, okay? So that's linear increase. It goes to the origin. And I picked 4, 8, and 12 because they're divisible. All those are divisible by 4. Okay, and here y equals negative 2x. That's a negative constant, so notice how the graph slopes down. You'll learn more about slope. Goes to the origin. So I pick my points. I can pick 0, 0. I can pick 1, I get negative 2. I can pick negative 1, I get positive 2. Draw my graph, and that's a quick way to look at direct variation. Just make a table of values. I can use really 0, 1, 2, 3 if I wanted to, but I picked some numbers that were divisible by 4 to help me with that fraction. They're going to be linear, okay, and they're going to go through the origin. So if you guys have any questions or comments about direct variation, you can email me at nicholas.bennett@dc.gov, or you can go ahead and type your questions below. All right, we'll talk to you soon.